Now, how do we make the choice of the communication channel? That is, which communication channel will be preferred? This choice we have to make. The choice of the communication channel depends on the nature of the signal. So, nature of signal decides the choice of the communication channel or the frequency band to be transmitted. So, if we wanted to have a TV communication, the ultra high frequency communication, or we have to have a radio communication, or we have to get the space communication, then according to that nature, we have to decide about the signal. Now, what is a space communication? Mention the different types in which the electromagnetic waves can propagate from one point to another point. Basically, space communication is related to the satellite communication, number one. Number two is the space communication means that is from Earth, we are communicating to the astronauts on the celestial bodies like Moon, like on Mars, or like in the intermediate space, we can have a direct communication with the astronauts. That is called the space communication. And this is carried out with the help of electromagnetic waves. And in the electromagnetic waves, it will be the first member of the spectrum that is called radio waves. So radio frequencies are used for this communication, and the radio frequencies are about 10 to the power 13 hertz. Now we proceed like this. The propagation of the electromagnetic wave, that is the space communication. The term space communication refers to the sending, receiving, and processing of information through the physical space as the communication medium. So, in the given figure, the space communication is indicated, and the upper zone is called the ionosphere. So, before proceeding forward, I will explain the various parts of the atmosphere. That is, first of all, there is a portion called troposphere, then comes, that is after troposphere, then there are different parts, like one is mesosphere, stratosphere, and the ionosphere. The troposphere ranges from sea level, that is 0 to 12 kilometers, and then comes, that is the stratosphere, that is from 12 to 50 kilometers, and then comes the mesosphere, that is approximately 50 to 80 kilometers, and finally it is ionosphere, that is from 80 to 400 kilometers. So it means that this is within the range of 400 kilometers. So now we proceed forward. The term space communication refers to the sending, receiving, and processing of the information through the physical space as the communication medium. In this type of communication, information is carried from one place to another by electromagnetic waves of high frequency. And these high frequency waves are either known as the radio waves or they are known as the carrier waves. So this is indicated like the ground wave, the skip zone, the earth is indicated by shaded region, the space wave is indicated, then it is written, that is, it is indicated by the arrow lines, that is one arrow is upward going and then it is reflected back from the ionosphere. So when we send a radio wave in the sky, it gets reflected from the ionosphere. The frequencies used in space communication lie in the range of 10 to the power 4 hertz to 10 to the power 11 hertz. More elaborately, it should be 10 to the power 13 hertz. And corresponding wavelengths lie in the range of 1 mm to 30 kilometers. These waves travel through the open space with the speed of light. The Earth's atmosphere helps in the propagation of these waves from one place to another. Radio, television, the satellite communication are all the space communications. And I have explained you the Earth's atmosphere extends up to 400 kilometers. The first part of the Earth's atmosphere is called the troposphere. The second part is called the stratosphere. The third part is called the mesosphere, and the final part is called ionosphere, where we find the charged particles. That is, the ionosphere means where the particles are ionized or we get the charges, and atmosphere has pressure very low. That is what the meaning of ionosphere. An electromagnetic wave radiated from an antenna can be transmitted through space in three ways. Three ways. Along ground, that is the ground wave. Number two, directly in a straight line through intervening tropospheric space. The tropospheric space will be from 0 to 12 kilometers. That is, it is extending right up to 12 kilometers from the sea level. The space wave or tropospheric wave or surface wave. Now we come towards the third concept, upwards in the sky, followed by reflection from the ionosphere, the sky wave or the ionospheric wave. Now our next question is related to the ground wave propagation. Why does the energy of ground wave decreases during its propagation along the Earth's surface? We are referring to Earth's diameter. Why is the ground wave transmission of signals restricted to a frequency of 1500 kilohertz? That is 1500 multiplied by 1000. That is 15 into 10 to the power 5, 15, 10 to the power 5 hertz. Now, ground wave propagation. A radio wave that can travel directly from one point to another following the surface of the earth is called ground wave. So, such waves which are moving from one point of the globe to another point, they are called the ground waves. So, ground wave propagation is possible only when transmitting and receiving antenna are close to the surface of Earth. As the ground wave glides over the Earth's surface, it induces the current in the ground over which it passes over. It's attenuated as a result of absorption of energy by Earth. And I have explained earlier about the attenuation. That is, attenuation is the energy loss of the signal. Energy loss of the groundwork increases very rapidly with the increase in frequency. Hence, ground wave propagation is possible at low frequencies, and these low frequencies range from 500 to 1500 kilohertz, or for radio broadcast at long wavelengths greater than 200 miles. This region of amplitude modulated band is called medium wave band. The maximum range of the ground wave propagation depends on the two factors. One of the factors is frequency, the frequency of the transmitted wave, and the power of transmitter. So what exactly we mean by the power of transmitter? Power of transmitter is, that is, how much energy is being transmitted by the transmitter. Because power is the rate of consumption of energy or the rate of doing work. To radiate the signals, when we use the signals, we are referring to the radio signals or the carrier signals. So to radiate the signals with high efficiency, the antennas should have a size comparable to wavelength lambda, at least lambda by 4 of the transmitted signal. Now we have to go through with some advantage and disadvantage of the ground wave propagation. So there are certain advantages. The first advantage is it gives enough transmitting power. Ground waves can be used to communicate between any two locations on the earth. Any two location means that is from the whole diameter of the earth, which is normally 6400 kilometers. Ground waves are relatively unaffected by changing atmospheric conditions. So they don't depend upon pressure, temperature and density conditions. Disadvantage of the ground wave propagation. The ground waves require relatively high transmission power. So transmission power must be very high. That is, energy must be very high. As a ground wave are limited to very low frequency, the low frequency and medium frequency signals, they require large antennas, and the length of antenna cannot be increased than 300 meters. Ground losses vary with surface material and composition.